Today we have a lot of stuff to talk about, so let's get to it. Some concepts that you guys need to be introduced to before you can continue working. So the first one is generics. And I'm going to try to get to the beginning of this. My mouse is acting weird. Come on, Zoom, quit it. I was just waiting for somebody, I guess. Okay. Let's see if I can get there. These last few things that we talk about in C#2 are going to really explode your capabilities as a developer. So if you can get these concepts in hand and in brain and utilize them, you'll be a much stronger developer than someone who doesn't have them. This stupid thing, it never works. It's plugged in. I'll just click myself. So, what are generics? Well, first of all, what's an overloaded method? It could be.
It's a method that has the same as the previous method, it's different. I can't think of the word right now.
Input parameters, like Taylor said. So our parameters or our return data type is different, but our method name is the same, right? So that's an overloaded method. And we could have an overloaded constructor. We saw that where we have like no arguments, one argument, etc. Well, we can get to a point where we have a lot of overloaded methods. We might have, you know, the print method in our program many, many times. So we have this ability to use a feature called generics. And generics are available both in C# and Java. And a generic is completely a compiler thing. So it doesn't really get compiled. It doesn't become part of your object code, your code that's running. It's only something that is used by the compiler. So it's used to keep our code from canceling at runtime. So what is a generic? Well, a generic lets you parameterize your data type. So you've probably run into this already when you were thinking and you were logically coming up with a solution. If there was just a way I could pass in whether this is an integer or a double, I would be able to do all of this other stuff. Well, a generic lets you do that. So it lets you say the data type is going to be determined later. So we can define a class or a method with a generic data type. And when our code is compiled, the compiler will figure out what the actual concrete type should be for that, and it will replace the generic specification. We use these angle brackets, the diamond brackets, the greater than and less than, to specify a generic. And a generic indicator is usually placed, the uppercase T and uppercase letter E are pretty standard, but you could actually put any letter there inside of that angle brackets, and that would become your generic specifier. Now you have to be careful. That's why we use an uppercase T and an uppercase E. That's just sort of what's kind of become common practice. So I can put this angle bracket T in my code, and the compiler is going to replace that angle bracket T with whatever data type is appropriate. So the T is actually referred to as the formal generic type. And when the compiler does that replacement, that's called generic instantiation, because we're instantiating or determining what this generic data type is going to be for our run. So how does it work? We put the T or E with the angle brackets around it in our code, and during compilation, the compiler figures out what the real concrete type is going to be, and the generic is replaced with that actual concrete type. So the generic type can only be replaced by a reference type or an object. So in C#, we have lowercase like int, and then we have uppercase int. The lowercase int is considered the native data type, the base type, and then the uppercase is considered a class. So it's an actual integer object. So what happens when we're using generic instantiation, we're always going to be using an object data type. So we could actually replace that generic indicator with football if that was our object type that we wanted to use throughout this implementation. So if we use the word int, double, char when we replace a generic, it's actually going to work. Everything's going to be fine. But that native data type will be auto-boxed, and that means that it's going to be automatically converted into an object data type. And we'll take a look at that a little bit more here in just a second, because there's some overhead associated with that boxing, that auto boxing. Now, the first example we want to look at of some generic code has to do with a stack. We'll talk about those here in just a minute or maybe next time. But a stack is a data structure. And a stack is a data structure where the last thing in is the first thing out. So here's a stack, right? This is a stack of plates. I like a stack of pancakes better because that sounds just delicious. But when I'm looking at a stack here, I can't just take this one out in the middle. It's really hard to take the one out at the bottom. I always have to take the one off the top. And that one off the top was the last in. So that data structure is a last in, first out type of data structure. Where would I use that in programming? Well, computers use it all the time, right? So if I am getting ready to run my program, the system is going to keep track of the fact that it is running the main method. Let's see if I can draw anything here. So I'm going to have my main method. And then my main is going to call some sort of input method. Well, the system internally is going to add that input method to the stack. The input method is going to call some sort of data validation method. That method is going to be added to the stack. Now our validation method is going to execute. When it's done executing, it will relinquish control and it will be removed from the stack. Our input method then will continue running until it gets done. When it relinquishes control, it will be removed from the stack and control will be returned to our main method that started the whole thing. So an operating system uses that stack structure all the time to keep track of what was called and how to return to the caller. So we use that a lot. That's a good structure. We like it. So if I were using a stack, I were creating a stack, I could use a class statement like this. So I've put this generic indicator here saying I'm going to create this new class called stack, and it's going to be using generics. Now when I create methods inside my class, I can use that uppercase T, that letter, in place of data types throughout my whole class. So here I could declare an array named items of whatever data type T becomes when we run this. I could create a method that returned an item of data type T. I could create a method that wanted an input parameter of data type T. So wherever these T things are going to be replaced by the data type that's actually being used when the program is compiled. So how do we know what that is? Well, it depends on when our class is instantiated or called, right? So this line of code right here creates an instance of our stack. So when we create an instance of our stack, since it uses a generic, we have to specify what data type we want to use. So right here we're saying create a stack using an integer data type. So everywhere in our stack class that we have that uppercase T, we're going to replace that uppercase T with the keyword int. So everything inside our stat class will become an integer. We could use the word double here, and then everything in our stack would use the double. So we can create some really, really dynamic classes and code by using generics. Whenever this is compiled, the compiler is going to take this specification here and instantiate all those generics. It's going to determine the data type. And then it can tell that we've got everything right. Now, what use is that? Well, besides the fact it makes things really flexible, before generics were implemented, people would use a base type of object because everything in C# eventually is a base type of object because object is our system object that everything is inherited from. So they would use that base type, and that way they could pass in integers or doubles or whatever they wanted. But sometimes they could have problems where they were doing invalid things like maybe sending it a string and then treating a string as a numeric object. By using generics, the compiler can catch data inconsistencies like that and prevent us from doing something wrong that would cause a runtime error. So that is what it's for, is to allow us that flexibility, but yet check us. All right, another cool thing, that's just kind of a side of cool things you need to know about. Speaking of data types, there is a data type called dynamic. So we can use a dynamic data type to store any kind of data. So these two examples show this dynamic int value variable is declared with a value of 1,000, so it becomes an integer. The dynamic string value variable is declared with a string value, so it's treated as a string. Whenever we're looking at dynamic data types, they're going to be resolved when our program is running. So they're very dynamic. They're kind of like, if you had Python in your 120 class, it's kind of like using a Python variable where it's going to figure out what kind of data type it needs. Why would we not use these all the time?
So much more space and memory.
Space and memory and just overall resources. You know, we're just going to use so much more resources not being specific with that data type. Remember, C# is type specific. It likes knowing data types. As soon as we take that away from it, then it's got to do all this extra work to figure that out. We've added overhead. We're going to make our runtime longer. But dynamic is available, and sometimes that's just the best solution for us, depending on our situation. Now, there's another option too, and that's the VAR data type. And the VAR data type can also store anything. Now, a little bit different than dynamic. VAR data types have to be initialized when they're declared so that the runtime system can figure out what data type they are. So I have to say equals something with a VAR data type. With that dynamic type, I don't have to. It'll just be resolved at runtime. So could be dangerous, but we can have more flexibility with C# than just the base data types. Okay, so what's boxing and unboxing? I said that if we use just an int, it was going to be boxed into an object data type. We actually have two types of memory that are being used by the C# runtime. We have what's called the stack and the heap. Now, if you look at this picture, it's kind of hard to tell, but the stack is just kind of like, I don't know, variables that we use as we declare them, minor things, just stuff. On the heap are things like objects, so very organized type stuff. So in this example code, we have an integer named I with a value of 1, 2, 3. When we cast this integer named I as an object named O, it becomes boxed. And that means that all of the information about this object is assembled and organized, and the data is placed on the heap. So it's moved from the stack onto the heap. Then if we're done using that object O, our garbage collector is going to come along and get rid of that stuff. But if we turn around and use I as an integer again, it's going to have to be unboxed. So it's going to be taken off the heap and put back on the stack. So when we do these kinds of things behind the scenes, the runtime system is going to take care of us. But again, it's going to add overhead and more resource requirements to our performance. So we always want to be careful of that. This link here is .NET Tricks, and they have a little explanation about boxing and unboxing. So not too different than the example we were looking at. Our stack is all of our variables. When we take that variable and turn it into an object, it becomes boxed and placed on the heap. They show a little further on down some potential errors you could run into internally from boxing and unboxing. In general, it's going to be something that just happens that we don't even really have to be aware of, just causing a little bit of resource overhead. So what is the stack versus the heap? The stack gives us really quick access. It's allocated when a variable, when our program is compiled, we are creating a list of all of the things that need to be allocated out of memory. So when our program begins running, the stack can be allocated because it's already been determined. We know we're going to need this variable, this variable, this variable. Now the stack is thread specific. So that means if I have an instance of my football class and I create another instance, I have a duplicate stack information, right, on that same stack. Now, we also are going to put native data like integers, doubles, things like that on the stack. Now, what about the heap? The heap is allocated in blocks. It's slower access. We allocate things to the heap when we're running, so they can be application specific. I said something about that football instance. When that gets allocated, it's really going to be on the heap. So each of those instances would have their own section of heap memory that they need. So all of our objects are going to be kept here on the heap. So when we're boxing and unboxing, we're just converting things from one memory type to another. But again, it can really slow down our performance. Okay, so generics. Generics are placeholders that are resolved at compile time. We actually won't have any assignments other than completing a REPL where you guys have to use generics. So this is something that on your own you want to be getting out there and exploring a little bit more, because this is like I'm saying, more advanced than a lot of other stuff that we've done. You're getting out there into the wild, wild west. Now, generics allow one block of code to process many different data types. They prevent runtime errors by allowing the compiler to validate objects' data types during the compile. And we have to remember that boxing and unboxing can cause unnecessary resource consumption. So those are our generics. Before we start the REPL, we've got to look at this other one. We'll go. It won't be very long, I promise. So much stuff. It still says chapter 8 in it. It's not. I think we're chapter 9 now. All right, so we've looked at arrays and arrays and arrays, and you guys have done stuff with arrays. And I told you there are more advanced classes available in C# than just arrays. So some of those might be useful for your assignments or for the repl. So let's talk about them before you're running off. All of these are collection classes. Anything in C# that has more than one is a collection. So we've used arrays. We have a more advanced class available called the ArrayList. The ArrayList is just like an array, but it gives us more dynamic capabilities about shrinking and growing and resizing and things like that. A string is a collection, right? Because I can refer to my string with square brackets and index values to get to the first letter in the string or the second letter. I also could set up a bit array, which is just one bit. We'll look at that. Some other items that we could use in C# are the hash table, the queue, and the stack. So in the last PowerPoint, we were looking at a stack class that we could potentially create that used generics, but really C# already has one pre-built that uses generics like that we can utilize. So a collection class. They're predefined classes, and they let us store and retrieve predefined objects. We might need a using clause in our code. We might need using system.collections. The ArrayList class is zero-based, like a standard array. So our first item is index value 0. It's a list-like structure that can dynamically increase and decrease in size, and it supports mixed data types. So at one time, in one array list, I could have a string, an integer, and a double. So I am not limited to one data type in this collection. So that's much, much more feature-rich than a regular array. Now, when we're creating an array list, we're going to specify that it's the ArrayList class. We're going to give it an identifier, and then we're going to instantiate the array list. So a lot like an array, but notice we don't have to specify any sort of size because it's just going to be dynamic. Now, the array list, being that it's a class available to us through C#, it has several methods available to us. And some of these are really helpful. Let's look at this list. We can add an item into the array list. So again, if you had Python, this is going to look a lot more like working with a Python array. You can clear the list. You could clone it to create a copy. You can find the last index of a value. You could find, I think, the first index of a value, like the number 7 or whatever it is you're searching for. You can sort the array list. You can convert an array list to a standard array. You can force it to trim down to the number of entries. If you read through the real specific details about an array list, there's kind of a formula as to when it will actually resize itself. And then there's a list. Now the list class, this is why we had to look at generics first, right? So the list class is just like the array list. It's a zero-based structure. It can dynamically increase or decrease. But this one is a little different. It can only be one data type in a list. So we're back to that kind of requirement, but it uses a generic. So it could be whatever data type we want it to be. So we could make a list, again, of football instances if we wanted to. Now, whenever we're using the list, by default, it's going to support whatever data type we put in as our generic type without boxing and unboxing. So it's going to help us performance-wise. So let's see, how do we create one? We specify that it's the list class. We resolve the generic by saying what data type we want to use. We give the list a name, and we say we want a new instance of our list, and then we have to specify that generic data type resolver again. So sometimes it seems a little bit redundant, but it's not. You just think about this really is becoming your data type, and we always repeat our data type again at the end when we instantiate something. So we're just using all of it. Okay, and then what about the string class? The string, if you remember from way back, is a collection of Unicode characters, those ASCII character sets. So the system has a predefined alias of string. So you guys could use the uppercase word string or the lowercase word string in C# if you hadn't noticed, and either one works just the same as the other because they're defined as an alias. Whenever we are using the equality operators, equal, equal, and not equal, we usually are comparing an object's reference, that memory location where that object lives in memory. Starting at this memory location, are you finding the same data as you find starting at this memory location? Now with the string, the equality operators actually compare the string object's value. So if you've had Java, you know that you have to do some special things to compare strings. In C# you don't, because those things are taken care of for you. So strings are going to be compared lexicographically, like A, B, C, D, E, that same kind of order. And with our string class, we also have a lot of methods available. Now the last thing, string objects are immutable. What's that mean? If I create this string called my string, it gets allocated in memory and it has this value, initial string. Now I come along later and I change its value. My string now equals another value, right? Both of those values remain in memory. The object, my string, its reference point, the place it's pointing to in memory, is adjusted to point to this second value instead of this first value. Well, that's cool. That's no big deal, right? But what if this string was something that occurred a million times in my program? Now I have this string sitting out here in memory a million times as I've changed it because it is immutable. It's not updating the original point in memory, the original location. It's creating a new location in memory and pointing to that. So that means that I have to be careful with strings. So you want to check out the string builder class, and especially for that assignment you have, you want to check out that string builder class. Whenever we're using a string builder, we're making our strings mutable. They can be overwritten. They become string builder objects. So that string builder is kind of on top of string. So it can be a lot more efficient for intensive string processing. And you want to remember string builder if you're going to go talk to O'Reilly's about their internship. So that's an important point. Okay, so with your, this one, you guys know what it is, right? You make me use it all the time. You made me use it, so I'm finally used to it. Our string interpolation, everybody forced me to start using, yay, last semester, which we should use, was just new with C# 6.0. So that was like Visual Studio 2014 maybe. So not that long ago. So if you guys go to use this someplace, remember the interpolation is where we're putting the $sign before the string, and then we're able to specify a variable name directly within our curly braces of our output. If you are doing that, don't be surprised if someone watching you doesn't know what you're doing, what's going on. You can explain that to them, that that's a new C# feature that hasn't been around for too long. All our important things thrown into these presentations. All right, bit array. This is cool. A bit array, again, is zero-based. It's just a standard array, but it contains Boolean values. So it's the same as me creating an array of Booleans, but there's a special data type or a special class in C# for it called bit array. So how could I use a bit array? Well, if I had like 14 things and I wanted to make sure that I only used each of those 14 things one time, I could create a bit array. Actually, this is 15 things. I could create a bit array And then if I used item 5, I would change it from false to true. And then I would be able to interrogate that and know that I had already used that value. Can you think of any other things that you would use that for? Like on, off, used, not used. One of the other instructors used to always do like a lottery ticket, generate a lottery ticket where you have like 6 numbers that aren't reused. And so the bit array is real important in that idea, because we want to make sure that we're not reusing a number. So any kind of instance you get in like that, where you have to make sure that something's unique, think of a bit array. This is a perfect implementation. Why? I'm only using 1 bit of storage for each of these values, just very minimal. So compare that to an integer array where I'm using, what, 4 bytes of storage for each of those values. It's substantially smaller, much less of a footprint. Now, when we create our bit array, it's a little bit different. So we're calling it a bit array, giving it a name, saying it's a new bit array, and then we are going to specify the size, but we're going to specify the size in parentheses as a parameter instead of in square brackets as an array index value, because it's a class. Here's one. This might be coming up. Were you to get an assignment that said you were supposed to be a parking garage, like later in the semester, you might want to use a bit array to keep track of which parking spots were already used, right? Because if we had 25 parking spots to keep track of, we could have a bit array with 25 entries and just set that to true if there's a car parked in one of those spots. So any sort of implementation like that, perfect for a bit array. Now, what's a hash table? Well, this is different. A hash table is a list of like hashed values. And a hashed value is where we send, say, a name through some sort of caching algorithm. We come back with a unique or potentially unique value that we use as an index to keep track of that hash item. So we should potentially be able to unhash it. In this example, we've ended up with Linda getting like hash value 1, Sam getting hash value 4, and Sandra and John getting hash value 2, which could potentially cause problems depending on what our implementation was. We might need to fix our algorithm, figure out why they're getting the same value. But we're trying to generate unique keys for each of these different items. So that's what a hash table is. Give us some different key values. Now, some other data types that we need to be aware of, and we'll have some short examples for these in the Rebels, is a queue. So here's a queue, right? That's a queue. A queue is English, like Great Britain, for standing in line. So those Brits, they go get in the queue, and supposedly, according to queue research and queuing theory, people from Britons, is that what you call them, are supposed to be the best at lining up. They do a really good job. They get in queues, they stay there, they are nice to each other. So us people from the United States, we're pretty good at queuing, right? We do it. I mean, we know that we have to. Sometimes when we're driving, we don't do it as well as we should. Now, my daughter's done a lot of traveling, and so once in a while, she gets a little bit racist. And she says that the Asian race is very aggressive in queuing. Is that true? I don't know if that's true, because I've never been in those situations that she has. She says like that sometimes people, maybe from Japan, are super aggressive at waiting in line. They like push their way. So queuing, can you believe that I said queuing theory? You could go get your master's in queuing theory. That's an actual like master's focused topic, because it's really interesting. How do people queue? How long will they wait? What kind of line will they get in? Would you get in this line? Well, it depends on what you're waiting for, right? How important is the thing that you're going to be waiting for is going to help you determine whether you're going to get in that queue. So queuing theory is really an interesting topic. Now, for us in software development, again, we use this concept of a queue of waiting in line all of the time. And we could see it a lot if we were doing coding, where we were doing some multi-processing, taking advantage of the multiple cores in a processor. We might have some code that needs to wait until other code has completed. And so if we were doing multi-processing code, we might have to put some enqueuing into our code to make sure we waited until everything was ready. We might also do it in a process mode where we have a Linux machine and we're going to run all of these scripts that come from all across the country, and as they run, they just get in line because we can only process so many at a time. So that would be a queue. Now, when we're looking at a queue as a data structure, it's a little bit different than the stack, because when we get in a queue, we assume that it's going to be first in, first out, right? FIFO, because I don't want to be waiting in this queue and have the person at the back get served before me. I saw that happen. You've seen it? I was at the airport in Springfield a couple years ago when I flew, and I was really worried, really stressed about making it to the plane because I hadn't flown in a long time. But I was waiting in line, and I waited in Springfield for a really long time. I was like, what's going on? And it was finally my turn, and I was going to go up to the counter and get served. And this woman comes up beside me and just swooped in. So she had like a VIP pass or something, and I was like, what's this crap? So anyways, you know, keeping the poor man down. Violated all of the queuing theory, right? These are things that I've known from the very beginning of time. I guess it's that way at Disney World. You have to buy the super pass or something if you want to get on any of the rides. That's a bummer. Okay, so when we get in the line, that's an NQ. When we finally get done and served, that's the DQ. If we are working with a queue object and we want to see what is next in the queue, we can peek at that object without dequeuing it. So these are the standard methods that are available for queue processing: NQ, DQ, and peek. Now with our stack, oh, I told you I like pancakes better. With our stack, those terms are a little different. When we put something onto the stack, we push. So I'm going to push more pancakes onto the stack. When we take them off the stack, we pop them off. And again, if we want to see what's waiting in the stack without actually popping it off, we can do a peek to see what kind of object is there. So we might have some examples there. So that's a stack. So queue, FIFO, stack, LIFO. Now there's lots more. Oh my gosh, you would never get to the end of all of the classes that are available with C#. So you could just look forever and ever. I want to show you our sort. I don't want to do it together. So if we were looking at our sort and we wanted to make it generic. Let me see if I can get this right here. We should be able to just add a generic indicator to our class name, and that seemed to work. So if I go down to where we're loading our array, I can use that generic just fine. I could change this to say it's a T, it's a generic type. It's a generic type, a generic type. So I can just put that uppercase T wherever I want to replace that data type within this class. So I could make this whole class much more flexible, right? I could pass in an int or a double or whatever kind of data type that I wanted. Now the issue is there's some areas where our code is dependent upon things being an integer, like here where our random number is generated. How could we resolve that? The other problem is, Control Z to put this back. Put everything back. I'm making a mess here. Sorry, I had too many changes. I didn't realize. Okay, so the biggest problem is right here where we're doing our if statement to decide if we should swap our variables in our sort. And it won't let us do that. It says that we can't do a greater than when we're working with operands of type T and T. So what we're going to have to do is implement an interface that allows us to put a compare to method here in our code to force the comparison of these two. So this is just a challenge for you if you have a chance to look at it, and I will try to look at it too, and we'll see if we can figure it out by Monday and show you how to implement the interface. Now, before we fight with that, I wanted to look at the REPL. So let's look at it together. This one is be calm and collected because it's collections. I haven't had to log in on this thing in a long time. So let's look at the first one. This very first one is a two-dimensional array. And there's some instructions here. It says, whenever we're doing a two-dimensional array, here's our syntax. We're going to specify our data type, and in our square brackets, we're going to have a comma to indicate the number of levels. And then our new specifier would indicate the data type of both of those entries. So in this example, they say use the array property length to output the size of the array and the property rank to output the dimensions of the array. Use the getLength method to output the number of rows and columns. So here's your expected output. So let's just put that in. I'm going to go right here to where that array definition ends. Put in some code. So I should just be able to console right line total array entries equal so is this one going to be length or rank or what? What do you think? Okay, length. Just takes a second to try. That looks right. Total array entries equal 12. And I used the dot length. Is everybody finding it okay? Yeah. Go back up. Got it. Is it working? Working. All right, so what would I do then to get the dimensions? So if I ran Visual Studio, it would drop down with that list, huh? And I'd be able to tell.
Rank. Yeah,
Rank.
So that just shows the number of dimensions of the array, right? So there was only one dimension, and then we come back to one.
One. So that one's 2 dimensions. So yeah, we could make a really nasty 3 or 4 dimensional array, but I don't know why. Let's just make an object and then we don't have to be so confusing. Okay, so next, number of rows. This one is to get you back into repl and saying bad things about it. Display colors dot what? Get length
And 0 your times.
with a 0. All right. Now it says it's get length with a 0. So I'm going to copy that line of code because I bet that next one's a 1. And that should say number of columns. Yay. That looks good. So I'm going to run it with the tests. And it says it passed. I could just submit. Now on this one, there's an awesome model solution. Probably looks a lot like the solution we just did. Yup. But don't forget that those are out there sometimes. Me and a whole bunch of other people have requested that they put a next button on the assignment. You can tell what they think. Okay, what's this one? Display two-dimensional array. Okay, again, we have our 2-dimensional array. And we want to revise this method, the list color entries method, to output the information in the array according to the specifications below. Output for each new row should be labeled begin row, and each entry should be labeled call number contains the value XX. So let's see. Create an initialized integer array. Code a method to output the array values. I'm going to do run tests because I'm not understanding. Oh, okay. So we just need to add a little bit. We want it to say begin row instead of just the row number, which is what it does now. And then we want it to say a little bit different here, column. So that's what the sample output is not very good. Let's fix it. So instead of just the row here, we want it to say begin row and then the row number. And then instead of just outputting the color, we want it to say something here. Let's see, COL space, and then our column number. plus a space, and then let's put contains a value. Is that what it wants? I'm going to run it. Oop. Left my plus sign out there. Okay, I think that's like what it wanted. That's not what it looks like over here. It needs to be updated. So I'm going to run the test. Oh, that looks good. So let's submit it. Get it? Okay, now the next one is a for each. Just practicing. Okay, so again, we have a two-dimensional array. And we want to change the output method to use a for each loop. So I'm going to just totally get rid of this for loop. I'll just change it here. For each it's a string. I'll call it entry in array. That's what's being passed to us. Now we want to output entry. I'll use this that's here. And then the actual entry we received from our for each loop. And then I can delete the rest of that. So remember, a for each loop makes it a lot simpler, but we can't access the index value or things like that. So, okay, let's run it and see if that looks right. Entry, I didn't spell it wrong. Run our test here. Oh, that looks good. Oops, I forgot to submit it all the way. Okay, what else we got? Declare a two-dimensional array. Okay. Create a second two-dimensional array. This array will contain 3 integer values for 4 days. Where do you want to put it? I'm going to put it after the call to that list color entries. Either place is fine. And we want this to be integers. So if I want to put those values in, I should be able to say 43, 50, 21. Oh, I need to put an extra set of curly braces around each row, and then a comma after each row. We don't define arrays this way very often, so it can be difficult to remember our syntax. Our second row is going to be 18, 90, and 77. Our third row, 11, 74, and 25. And finally, our fourth row, 93, 3, and 56. So we need a new method to output that array. So I think it can be a lot like this one that we already have. List int entries. And our parameter will be an array of integers. Call it days. Now, just like listing our color entries, we're going to need a nested loop, a nested for loop, because our outer for loop is going to process our rows, and then our inner for loop is going to process our columns. C# is called a row dominant language because the first index always refers to the row in a two-dimensional array. Okay, so I'm going to copy this line of code and its curly brace. And instead of array, I named this one days. So my outer for loop is going to be controlled by the length of my days array. And the first thing we want to do in that is output our row number before we call our inner for loop. So I'm going to copy that line of code that does that right line. That should work just as is. And then I'm going to copy our inner for loop. And that should go right below that right line. Now in our inner for loop, we're going to be processing each column. Again, our array name is now days. Get my curly braces lined up here and close that one. Now in our inner for loop, we just want to write out the contents of that entry. And again, we're not using array, we're using days. So now we've got COL and the value contains the value. And we're replacing those parameters with our column number and our days number. I have not tried the interpolated strings on repl. I figure it will blow it up like crazy. Does that look good? Let's run it. Oh, where am I? 17. Do I have extra curly brace? Yup. Let me try that again. Now I'm missing a semicolon.
I think we need to delete the whole list colors entries.
Do what?
To make our output match.
Uh-huh.
Delete the whole list colors one.
Mhm.
Because your output just wants the number. And so it's delete the entire list colors array.
Oh, you could just, let's just comment it out.
We you could also get rid of the array, or it will.
Does it get all mad?
Well, it says like, I think it says like never used beginning.
Oh, okay.
That's part of your output for whatever stupid reason.
19. I'm going to fix this first. What's it mad at me about? I have got this method right within my main. So I'm going to add a closing curly brace. I'm doing, oh no, curly brace stuff. And I'm going to get rid of, there's that one. Now, since I've added my closing curly brace to my main, let's take a look at it. Our main is going to allocate this color array. And they're saying that it's not going to like that. So let's comment that out. Then I'm going to allocate my new integer array. I need to include a call to our new list int entries. And we're going to pass it our days array. How are our errors? Is it better? Looks better. Let me pull this down so you can see more of it. I don't know if you're having trouble with all of that messing around. So we declared our two-dimensional array of integers. And then we called our new method to list them out. That should work. All righty. Okay, this one says to copy your completed code from the last assignment. Use it to replace the main class in this assignment as a starting point. A new method that calculates the average for each of the days or rows in the array. The method should expect an array of integers as a parameter. A one-dimensional array should be returned containing the average for each day. In your average method, you're going to want to declare an integer to hold the sum. You're going to declare a one-dimensional array of integers to hold the average for each day. Then you're going to use a loop to process each row. Your inner loop will process each column. For each column, you're going to add the amount to the sum. When you've processed each of the columns, you'll calculate the average for this day or row and save that in the one-dimensional array. And then you'll reinitialize your sum to 0 to start again for another row or day. You need to update your main method to call your calculate average method. And we want to output the average array. Adding to that existing output with the average. Now I'm going to go back and we're going to look at the next one. So I'm going to leave you to yourselves. The ArrayList class, 3.1. Now this one should be hopefully self-explanatory. Just going to walk you through using the ArrayList class. And there's already some existing code. But it wants you to create the display contents method. So you're going to process that array list that's already been created. the string and bit array, this main class already contains a bit array, and it contains an array list. It adds some names to the array list. And then it checks to see if a given name contains the letter A. If it does contain the letter A, it sets the bit in the parallel bit array true for that entry. And then we'll output each of the names with a true-false indicator to say whether or not they contain an A. Now, this program should already be working. It needs to be updated so that an uppercase letter A will also be considered. So that shouldn't be too bad. And then the last one. In the last one, you just have a Hello World main class. And it wants an application that creates a two-dimensional array, prompts the user for the size, and fills the array with random numbers, which we should have some code for, right? Because we just did that the other day. Then it searches the array for the largest value, displays the largest value, and the index is where the largest value is stored. Now this one, again, you should have some existing code from our sort program that we wrote the other day, and then you'll have to supply some code. So you might want to do this one in Visual Studio and then copy it to REPL because it's pretty much, you know, a little bit more of an application. Now I'm going to leave these last ones to you. I wanted to work together to get them going so you get that confidence, movement, momentum. But now I'm going to leave them to you for the rest of our time. Next time, we're going to be talking about XML files. And remember that Pig Latin one will be due on Wednesday next week. So do look at that string builder and those string class methods for that Pig Latin, because there's some methods out there that are going to really help you a lot with it.